Hi! Today I want to elaborate on a short video I made a while ago. I think it's actually the first video on my channel about new elements. I've done more research since then, and I think I need to clarify a couple of things, but I'm also just going to talk about it as a whole. So let's jump in. So for decades, chemistry's been built around the s, p, d, and f orbitals, but quantum mechanics predicts another level beyond that, the theoretical g orbital. Now, this isn't new. It's been predicted for decades. If scientists can one day create elements heavy enough to start occupying it, then we'll be discovering an entirely new kind of chemistry. And that's really, really exciting to me. And that should be exciting to everybody, in my opinion, because without chemistry, we wouldn't have anything. Everything is chemicals, other than, light. So the G subshell is the next predicted subshell after F. The G subshell consists of 9 individual G orbitals, capable of holding a total of 18 electrons. Each orbital has an incredibly complex electron density pattern. These shapes represent the region where electrons are more than likely to be found. They're not flying around in neat circles. We know this. Now, although no ground state element has any electrons occupying a G orbital, calculations do suggest that they could be very important with atoms that have an extremely high atomic number. The reason why some elements are more reactive than others is because of the number of electrons they have in their outermost shell. Atoms tend to gain, share, or lose electrons so that they can reach a lower energy, more stable state. They'll do whatever they can to settle down. By understanding these patterns, chemists can predict how super heavy elements might react before we've even made them. But making a new element isn't as simple as just, mixing stuff together in a beaker. Scientists used particle accelerators. These machines launch atomic nuclei at incredible speeds and then smash them together. Most of the time, nothing useful happens, but every once in a while, one of those collisions creates something that's never existed naturally on Earth before. One example is americium, atomic number 95. It was first produced by bombarding plutonium with neutrons. One of these neutrons underwent beta-minus decay, transforming into a proton, changing the atomic number from 94 to 95. Scientists can also create heavier elements by fusing atomic nuclei directly together. It's less like building with Legos and more like trying to get two angry porcupines to hug each other at 10% the speed of light. So if researchers eventually are able to synthesize elements heavy enough to begin filling these orbitals, as I said before, those elements will display chemical behavior unlike anything we've ever observed. That doesn't necessarily mean that the G orbitals are going to just magically stabilize these elements, but they will represent entirely new electron configurations. This is going to give chemists a completely new region of the periodic table to investigate. As we approach the end of the periodic table that we know currently, the simple picture of neatly ordered s, p, d, and f orbitals starts to just fall apart. In these enormous atoms, electrons move so fast that relativistic effects start to change the energies of the orbitals, making their chemistries increasingly difficult to predict. Now, it depends on the model that they use. I know in my previous short video, I said that element 120 theoretically should be the first one to access the G orbital, but it depends on what model you use. If you use a non-relativistic model, it's better for, smaller atoms, things that aren't so heavy. And then once you get into the heavier elements, of course, you have to use a relativistic model, which is going to give you a different outcome. So I know I was reading a paper from 96 from a Japanese researcher, and I believe they said, it could be 126. So we don't know. We're pretty confident that something like this is going to happen in the next period of the table. And we don't know exactly how it's going to affect the things we have in place right now. Nuclear physicists do predict something called the island of stability, a region where certain combinations of protons and neutrons could produce super heavy nuclei that survive much longer than we expect. If we ever reach that region, and atoms ever become heavy enough to start filling G orbitals, we'll be exploring chemistry no human has ever observed. And that sentence would have sounded completely ridiculous 100 years ago, but then again, so did a lot of sentences. It's incredible to think that within our lifetime, we could continue extending the periodic table into territory no one has ever even witnessed. The Manhattan Project and the discoveries that followed gave us transuranic elements like plutonium and neptunium, expanded our understanding of atomic structure, and showed us just how strange matter becomes beyond uranium. The next great discovery probably isn't going to be just another box on the periodic table, but hopefully an entirely new chapter. And I think that's neat. Now, I did as much research as I could before making this video. I try to study when I can. I'm not a professional. Don't put me in a lab, but I think this stuff is really cool, really interesting. Science is always evolving, so I would love to hear your thoughts. If you guys have any papers or resources that you want to drop links in the comments or something like that, I would love to see it. Please stay curious, and I hope you have a great day.